So the free response questions on the AP Pre-Calc are pretty consistent. This is an example of FRQ1 where the focus is on composition of functions and then looking at graphs, evaluating them, looking at transformations, zeros, analyzing the end behavior, and then also working with the inverse functions. So if we take a look at this first example, it gives us an f function in the graph and a g function as this equation. And so looking at the first problem is the composition of functions. It is g of f of x. So if we're looking at that function notation, here we'll work with the inner function first, which is the f function. If we're evaluating h of 2, that means we plug in the 2 for the x. And if we go up to this f function, the input of 2 yields an output of 6. So we can replace f of 2 with 6. So the next step is to evaluate our g function, which is this formula right here, or equation, for 6. So we have two options. One, we can plug that g function into Desmos. So if I type it in exactly as it appears, so there is my function and there is my graph of that function. Right? I could just evaluate g of 6 by typing that directly in. And so I get my answer here to be 0.1426. Now, I have another option for this, and that is I could type this entire equation actually directly in my answer field, and I can replace the x with the value at g of 6, so I can replace that with the 6. And when I do, I get my answer. You can see that these are the same calculations here and here. Okay, for how many values of x does f of x equal -1? Well, if we come up to our x function here, and -1, when we look across, the output has 1, 2, and a third output of -1, so that would be your answer. There's 3 values of the f function that equal -1. Next, if we move here back to the g function, find all values of x for which g of x is equal to 4. So once again, what we can do here is we can come into our function, draw in the line y equals 4, and we can see where does this intersect. There's only one spot where that's the case. So negative 0.5263 is the only point where that intersects. Looking at the end behavior as x approaches infinity here, we can see as it gets bigger and bigger, it never quite reaches, but it does approach a value of 0. And then returning to the f function, does the f function indicate an inverse? Well, in order for it to be an inverse, the original function needs to be 1 to 1, which means it has to pass the vertical line test, which it does, and the horizontal line test, which it does not. So you can see there's multiple outputs or multiple inputs that give the same output, therefore it's not going to be an inverse. So we'll say no, and the justification is what I just said. It has outputs that are not mapped to unique inputs, and so that would be your solution.